Welcome to today's podcast of Building Connections. And today, on the topic of AI, we have with us Professor Tom Heskes, Professor of Artificial Intelligence and Computer Science of the Radboud University here in Nijmegen. So Tom, thank you for being with us.
Yeah, my pleasure.
Yeah, and it would be great if you can explain a little bit of what you're doing in your field of research and what Radboud University is doing on AI in general.
Yeah, okay, great. So I'm a professor in artificial intelligence and in specific, so more specifically machine learning. So we try to kind of learn models out of data.
Yeah.
So that's what my research group is working on. So I have a research group with about 10 PhD students, a couple of postdocs, a few other staff members. So we really like to understand why machine learning algorithms, AI algorithms work the way they do. And then we try to apply them in all kinds of different domains, scientific domains, industry, medical domain, basically anything. So that's my research group. And then at Radboud University, we have a platform which is called Radboud AI, and it's kind of a combination of all kinds of different researchers working on artificial intelligence. Because nowadays it's kind of spread everywhere, as you probably realize. So I'm in computer science, hence kind of the title Professor in Artificial Intelligence and Computer Science.
You're right.
But there are also people approaching AI more from a cognitive angle, trying to understand how the brain works and so on. Large language models are really popular these days with ChatGPT. So that's faculty of arts, language and arts. And then medical faculty, lots of applications of artificial intelligence in the hospital, or at least we're working towards that. So different faculties and we're combined in Radboud AI.
Right. So because there's so many types of AI, you just already mentioned them. So you work in the field of machine learning. Can you explain a little bit how machine learning fits into the, let's say, overall AI field? Like you just mentioned, multi-language models like ChatGPT. How does machine learning fit into that?
Okay, that's a good one. Well, so for me, artificial intelligence already exists for like 70 years or whatever. And it started with rule-based systems, right? So that I can talk to you and you have a lot of knowledge about facility management, whatever. Right. And I ask you to kind of write them down and I turn these into rules, like if this, then that.
Were they not referred to as knowledge systems?
Yeah, knowledge systems, expert systems, rule-based systems.
Years ago.
So that's how AI started, basically. Which is still extremely useful, by the way, right? So it's not that we shouldn't do that anymore. Still great. Since about the 80s, I would say, there is machine learning. And machine learning is about kind of learning models out of data. And these models can even be rule-based models, right? So instead of asking you, I would say, just give me the data. I'm going to learn rules based on the data.
So is that more kind of statistical approach then?
It's a statistical approach. Right. So for me, the distinction between machine learning and statistics, it's kind of almost the same, I would say.
Blurry. Almost.
It's very blurry, I would say. Yeah, definitely. So, and a good example of that is spam filter, right? So we will all use spam filters, and spam filters basically learn based on data.
Right.
Because once in a while, there is a spam message that gets through, and then you say this is spam, and then the filter kind of learns the next time a similar kind of email should be put into the kind of spam map and not in the ham map, right? So it learns, so that's great. So that's machine learning. Well, since about 10, 15 years, deep learning is kind of back because we used to have it, but now it's kind of much more popular these days because we have more compute power and so on.
Can you explain about deep learning?
Yeah,
I guess many people actually understand what it is about.
Good point. So deep learning is machine learning, but then with what we call deep neural networks. And neural networks are basically statistical models, but they are a bit looking like how the brain works, right? So you have layers, which looks a bit like the visual.
When you have inputs and it creates one output each let's say computer neuron would create one output out of inputs, and you can add layers of neurons to it. That kind of.
And we had been using them for already quite a long time. At some point, we thought that one layer in between would be good enough. But then we started realizing that, well, actually, if you use many layers, it gets better. And we didn't really expect that, but for some reason. But anyway, so now we know that if you have many layers, so that's why they are called deep neural networks, we can better kind of represent problems, in particular for image analysis, computer vision, then also speech, and then also language models. So so now for kind of image recognition, computer vision, speech recognition, speech analysis, and
speech to text, that kind of
and speech to text, natural language processing, deep learning is impossible to beat with any other techniques that we currently have. Right. So that's why everyone jumped towards deep learning.
And if I understand it correctly, one of the problems, so to say, around deep learning is that you build up a great algorithm, but you cannot express how the algorithm actually works, how it really operates, right?
I don't know.
Is that correct or not?
I wouldn't say so. So I also think you have to make a difference between not understanding how the algorithm works and not understanding what the model does that you get at the end of, well, when the algorithm is done, basically, right? Yeah. So the learning algorithm that people use for deep learning, it's pretty well understood, I would say. So the typical algorithm is called back propagation. And basically, you have an error because you make a mistake at the end and you propagate it back through the network, right? Yeah. So you go forward, you go backward. Okay, cool. Works. But then you get a model, and that model is quite complex, right? So that's maybe the distinction a bit between machine learning and deep learning and good old statistics, where we had relatively simple models that we could more easily understand.
But also explain, because it's just a set of algorithms that are linked in certain ways, so you can actually backtrack every kind of, let's say, decision made.
Yeah, but it depends, because in statistics you also have quite complex models, even linear models. If you have many input variables, they can be pretty complex, and then it's not so easy to explain. Explain how they work. So explainability is a hot topic in machine learning and in deep learning in particular. I wouldn't say that we cannot understand these models at all, right? But not at the level of kind of this neuron does this and this neuron does that, and this is how they are connected. But why should we, right? Because if I'm talking to you, I also don't completely understand what neuron fires in your brain and why, and I don't care, right? I just want to kind of understand what your output is and what you're trying to tell me, right?
In terms of the output, because that's what I read in research papers, or at least in publications, that, for instance, the famous example of let's say incorrect answers by the AI, or even, let's say, less polite answers of the AI. Basically, it needs a kind of, let's say, management of, okay, what kind of questions could you actually ask to the AI? What kind of responses are basically civilized and which are not? These are typical things that we basically seem to struggle with today.
Definitely.
And I have the impression that they are partly related to this understanding how the AI actually processes a question.
Could be, but I'm not even sure, right? So I guess you're referring to JetGPT, right?
Yeah.
So JetGPT, the output of JetGPT looks like kind of real English sentences or Dutch sentences or whatever, Italian or whatever. It doesn't really matter. It looks kind of pretty nice, but you cannot really tell whether it's nonsense, yes or no, right? So but even if you would understand the inner workings of the model, you cannot find inside the model whether it's correct or not, right? So it's I'm not sure if explainability is the issue there.
Okay.
And politeness is.
What do you see as the issue in the context of the problems as I just addressed? What do you see as the issue to solve?
So for ChatGPT, it's things like, well, definitely fairness and politeness and things like that, right? And kind of moral feeling, or
morally. Yeah.
or
Which is
or
of
what,
course it's different in Europe than in China.
yeah, it's different in different places, and so so we need to tune the algorithm towards kind of being being morally right in one way or the other, right? Because based on the text that it gets, right? Because it's basically a statistical machine. At the end of the day, it's just kind of number crunching. It cannot know that, right? So it doesn't have that kind of information. So how can it tell? So what happened with ChatGPT, of course, is that there were many kind of people that looked at different prompts and then determined whether that prompt should be answered by ChatGPT, yes or no. And then there's another classifier on top of ChatGPT that
right. And to explain for those who are not so much into AI, a prompt is actually a kind of question that you ask an AI.
Yeah.
Right. Okay.
Yeah.
So, in terms of when you see this this technology evolve, it's super fast, right? It's actually, when I look from the outside, it looks like as if over the last, let's say, 2 to 3 years, it went exponential in terms of how it entered the marketplace and how people were basically confronted with it.
Okay. I can see that. Yeah.
And I see when I look in our fields of operations, which is real estate and facilities management, that professionals are asking themselves, what is this going to imply for me in my, let's say, knowledge-based job for the future?
Yeah.
So let's say, just to word one of the uncertainties, it's going to replace me in a few years from now. So let's take that as a statement or a thought in the mind of professionals. So how do you look at that kind of future for knowledge workers in the future when you look at AI developments as going on today?
Yeah, so it depends on your job, I would say. So with all technology, right, and that's already, I mean, if you go 100 years back, I mean, things change, right? So at that time, I think most of us were farmers here in the Netherlands, and now, well, it's maybe only 5% or even less, and then it was more like 60 probably. So things change, and with AI, we will also see changes. I'm not sure how drastic they will be, right? So we just have to see that. So if I think about ChatGPT now, for example, it's a really cool system in some sense, but it's not going to replace lawyers or physicians or, well, people who really have to think in a clever way about text and what to do with that, right? So I cannot help remembering when I had a discussion with a lawyer quite some time ago, but he said, well, if AI really gets through, then I don't know what to give to my interns, right? Because all these kind of standard contracts, then probably an AI can do that. Yeah, for sure. So the standard contracts probably within a couple of years, or maybe already now, some of them can be done by an AI system or some automated system. And then the interns, they have to do something more clever, which is good, I guess, right? So they can spend time on other stuff, but you still need the interns and you still need the lawyers. And that will take, if you ask me, well, at least another 30, 40, 50, maybe more years.
Right.
Before we are at a stage that the really clever things can be done by computers. Yeah.
So then, in that context, when you talk about 40 years ahead and clever, how do you define clever then?
Yeah, that's always a difficult one. I think at this point where we are with artificial intelligence, that associations, right, between kind of an image and what it looks like and what it's supposed to mean, well, not maybe mean, but what it represents, that we can learn, right? And statistical text and things like that, it's probably fine. The real meaning behind it, it's difficult still. Things like cause and effect, really difficult for AI systems. We're still struggling with, for example, if I used to play table tennis when I was a kid, and I was pretty much okay in that. And then I started playing tennis, and well, that went easier for me probably than for someone who hadn't played table tennis before.
Right.
For AI systems, that kind of transfer knowledge is not so easy Yeah, well, we're working on that.
Yeah.
But we're not at a human level.
You're not so optimistic on, let's say, the acceleration of pace in that, in terms of development. Yeah.
I think there's
40 years.
I still think there are huge hurdles, right? So we've seen with computer vision and image recognition that at a very fast pace, image recognition got at the level of human performance. And then it's really a breakthrough because then, well, like you said, then you can start thinking about, for some tasks, replacing humans with computers.
Right.
I think for language, we're not there yet. I mean, definitely for high school students, right? So writing reports, ChatGPT can be very useful.
Yeah.
But when it's about really the content and really understanding, we're not there yet. And I also don't see that we really have a clue how to get there, right? So we need more. We need different paradigms. We need other stuff than what we're currently doing. Okay. Which is very much statistics based, kind of counting.
Yeah.
Because after this word, we often see this word, right? So that's kind of the way ChatGPT works, but then at a higher level, of course. Yeah. But still, that's the way it works, right? Counting. So.
Yeah. So because it's interesting as you state this, because at the same time I read in the papers or social media, whatever, I read these statements of industry leaders who say, well, there's a certain percentage of people thinking that there's a certain percentage of risk that AI will lead to the annihilation of the human race itself, you know? And how do you look upon these types of, let's say, statements made? What's your interpretation on that?
Yeah, so technology you can use for very good purposes and for very bad purposes. And that's what we've done in the past, and that's what sadly we will do in the future as well, right? Yeah. So AI, if I think about the interpretation of medical images, I mean, great, right? Yeah. We should try and improve those. But when we improve algorithms for doing that, then the algorithms for recognizing faces and then sending a drone to someone and whatever will also improve, right? So you can use them in a good way, you can use them in a bad way, and it will happen. And we have to be very careful there. So we have to kind of make sure that we develop algorithms and that we use them in a responsible way. And we need legislation for that, and we really have to think about that. So for sure. Then there is the issue of, will computers kind of take us over and stuff like that? I think we have watched too many science fiction movies. So that's not going to happen anytime soon. But of course, we have to be careful. But there are much more pressing issues these days than kind of worrying about that. And if we, so someone said if we have kind of 5 people in the world kind of thinking about how to prevent that to happen, and then the others can all work on issues that are much more important these days than the risk of robots kind of taking over the world. So maybe one kind of slightly less worrying issue is that we do have to be careful, right? Because sometimes it happens that we ask a computer to solve a particular problem, and then it solves it, but we didn't give it all the constraints that we should have added, right? So like with ChatGPT, so give me some text, but then the text might be impolite, but we didn't ask it to be polite. We didn't add that constraint that it had to be polite. And then things might go wrong, right? So that's what we always have to keep in mind, that we have to be very careful in what we ask computers to do.
Right. Yeah. Right. You just made a reference to this. You named legislation. Yeah. Now, the EU, of course, is seen as a front runner in creating legislation. How do you look on what kind of legislation is being put out as it impacts your field of research, perhaps? And how do you look at that initiative in general?
Well, I think, first of all, it's extremely good. So we have to be really careful. And so legislation is very important. There has to be a balance, right? Because if, as Europe, we're kind of a front runner, but so far ahead of the others, then we're also kind of maybe impacting research to the extent that the others, that we cannot keep up. And we already have a hard time keeping up with the Amazons and the Googles and the Microsofts and the OpenAIs and so on.
Right.
So we have to find a balance there. that we don't lose the battle and the others just go on, and we are kind of stuck with legislation that prevents us from kind of keeping up.
Right.
So that balance is the one that we have to find. But we have to be always on the right side of that, right? So we have to be careful there.
So do you have the feeling that the current legislation in the EU is limiting your research already today?
Well, not today because the rules didn't start yet.
No, yeah, you're right.
No, so, but, no, but yeah. So we have to be careful. So there, so development of algorithms, I think remains always very important. For example, there are rules for facial recognition and for face recognition, and I fully agree that in many settings it should not be allowed, and I think for facility management it's also extremely relevant.
Yeah.
So need to be careful there, but I don't think that should immediately mean that we shouldn't try to develop better algorithms for face recognition, right?
Yeah.
So because that might still be important for some other application that we do want to have, so for criminal behavior or whatever, right? So there are applications where we want to have good face recognition. So that balance is the one that we have to find. And in some cases, I think the current laws are a bit too strict. But that's the way it is, right? So and we have to keep on discussing those.
We are probably being confronted with the same kind of situation, because when we sell our material, our solutions with, let's say, for instance, face recognition in Asia, we have much more opportunity to do that because the legislation is completely different from that from Europe. We still have one product, of course.
Yeah.
So that's going to be kind of sensitive domain in the years to come.
And then probably you also have to think about what you find moral, right? Or not?
Yeah. Yeah, well, that's, I think...
But I don't want to turn the kind of interview around.
I think it's an excellent point to make, because part of the agenda for facility management is how to manage the workplace.
Yeah.
And under what conditions you're going to know about what's really happening, so you can basically put the infrastructure in front of your clients, so to say, and the users of the workplace in a method and that really fits to their needs. So you would be inclined to basically look a lot by cameras and to understand patterns and behaviors, but there's some limitation to that. And also, what you say, what's acceptable in that realm as well. And we still have to learn a lot about that, I guess.
Yeah, I guess so.
So
we all do.
Yeah, we all do. Yeah, it's something that you can just on a day-by-day basis learn around and basically.
Yeah, and I think we have to do that, right? So stopping kind of research and stopping development is not the solution, because then you don't learn, right? So you have to kind of develop in a safe environment.
Yeah.
To make sure that you learn these kind of things.
So just thinking of that, just as a side path, would you state then that certain institutes like the university should have a broader allowance for research and scoping than, let's say, an industry like Planon would have?
I'm afraid so.
Yeah. Are you thinking about that?
Yeah, no, definitely. And I think in the rules, that's also kind of the idea behind some of the rules that are there. They're more strict for industry if you're going to sell stuff than when you're going to do research.
Right.
Yeah. But there are some exceptions, and but that's too much detail.
Well, coming back to, let's say, facility managers, real estate managers, and other knowledge workers in our field. As we are looking at it today, AI might be just a great tool to enhance your productivity in areas.
Definitely.
So what's your advice to, let's say, facility managers or knowledge workers in the field of real estate? Because that's on the commercial side as well, of course. How do you understand market conditions changing? Would AI play a role in that to understand more? Because I think one of the great things, in my view, about AI, a computer can basically cover terabytes of data and produce a result out of data, while we, as a person, I can read a book, 200 pages, but it takes me 10 hours, whatever. We can't overlook that amount of data. And I think many professionals struggle with, what's all happening in my world? Only in facility management, real estate, the number of publications is massive. There's scientific information coming out on psychological behavior that is relevant to the workplace. As you basically, you don't have the time to read.
Yeah.
So what's your advice to knowledge workers in this field to basically use the technology to their advantage? How should you go about how to address this field? Because I have the impression that many professionals still have the notion that, well, this is important for the technology, it's not for me.
Yeah, so for me, AI is very broad, right? And you really have to kind of think about the specific AI tools that are out there, and then discuss each of them separately. Because if I think about ChatGPT and language models, then I can imagine that there will be tools around that will really make things easier in terms of summarizing information, like publications and so on. And so that's kind of specialized to your own interest, and that already kind of works. So if you kind of buy some of the products that are out there, you can give it a whole document of 20 pages and give me a summary of like half a page, and it's really useful. So you don't have to. So you don't need someone to write your management summary, because tools can do that, right? So that can be really useful. So these language tools are out there. Then if we think about computer vision, then most of the things at some point in time will be built into the cameras, right? So they will be embedded, and then you don't even notice it. Like in your mobile phone, you don't notice that there is a lot of AI in there. So in that sense, you perhaps don't need to care, but you of course have to think about how to use it and to use it responsibly, right? In a responsible manner. If I think about forecasting, right? I guess in your field there was a lot about forecasting. I have to warn you, deep learning for forecasting doesn't really work. So it's more like the more classical machine learning, which hasn't seen the same kind of speed up as with deep learning for computer vision and language models. But definitely there's a lot that can be done there. And I think collection of high quality data is very important there, because it's garbage in, garbage out. Right? So, and it's for all machine learning, but definitely if you want to do forecasting.
So you're still looking at forecasting as and when you take that to the AI sphere, it's more like heavily linked to statistical analysis kind of thing.
Definitely.
Right?
Yeah.
And not so much about in the deep learning in terms of multi-language models that will basically pull out the information and so on, that kind of thing.
Large language models are not good at forecasting. They have a specific task, and that is analyzing language, right? And modeling language. And for forecasting, they are useless.
Interesting. So, because I think there's some perception, at least when I talk to people in this environment, because we are, of course, novices in the world around AI, that there's this expectation that multi-language models, let's say, so to explain a little bit, perhaps the AIs that combine computer vision with language capability and so on into one, let's say, model, that they will be able to solve all these kinds of things, including prediction kind of stuff. So, getting to the question, what will they not be able to do that you might be interested in as a knowledge worker?
Yeah, so what you have to keep in mind is that these models work because there is lots and lots of high-quality data, right? So text, lots of Wikipedia, newspapers, and everything is kind of digitally available. And the way that they work is that essentially they try to predict, the base models, they try to predict the next word in a sequence. And there's lots of data for that, right? So the task of predicting the next word, given the last 20 words, you have lots and lots of data. A bit the same for images. There is lots and lots of annotated images because many people kind of play games and they Amazon Turk, whatever, they get images and then you have to classify them, and people like that. So there's lots of annotated data. If you think about facility management and occupation numbers of buildings, there is not so much information out there, I guess, that's really available. So what can you give me as a data scientist and machine learner to train these models on? I mean,
Yeah, well,
crap,
effectively what I'm seeing today is IoT moving into these workplaces with sensors, people sensors. So, and in order to basically capture some of occupancy data and using that.
No, but that's very useful. But and I still think that you can make prediction models, but the deep learning models that work on kind of huge amounts of data and also have a specific structure, right? So it's for a reason that deep learning works, because there is a lot of structure in image data, right? So it's kind of local features and more global features and much more global features and so on. Right. So there is a hierarchical structure in there. Right. There's also a bit of hierarchical structure in language, right? Kind of short pieces of text and longer pieces of text that are related and so on. If you can tell me that there is this similar hierarchical structure in occupation numbers, then maybe we can get a go at it. But I don't think so. It's much more kind of flat data in a sense. Yeah. And then the good old kind of machine learning techniques, they can definitely go for it, but it's not gonna be as sensational as ChatGPT and definitely still better than humans, by the way. Right. So it's not that it's worse than humans.
No. It's not better than humans, perhaps, or at least it can overlook more data.
Yeah, it can overlook more data. It might be less biased, So I remember, for example, so we did long time ago. We did a project for the Telegraaf. Yeah. Trying to predict their single copy sales.
Telegraaf is a newspaper.
Yeah, sorry, newspaper in the Netherlands. They have a lot of single copy sales. So you go to a supermarket or to a little shop somewhere, and then you can buy a newspaper.
Right.
So we built a system for them, a forecasting system that could predict kind of next day or next week single copy sales. They also had kind of their own people kind of looking at the data and then predicting the next day sales or whatever. So what happened was that our system was definitely a lot better, because the humans were kind of biased in the sense that when sales went down, they immediately kind of also lowered the prediction for next day, right? So they were much more jumpy.
Sensitive to the trend.
Well, or sensitive to the fluctuations, I would say. So if it's a trend, you should follow it. If it's more like the fluctuations,
short period,
you shouldn't follow it. You should look much more at kind of the average. Right. So, and the machine learning systems kind of learn that. They learn that that's kind of the better strategy. Right. But humans are a bit biased. They think, oh, what happened? So I have to kind of lower, right? It's not the case. So in that sense, I can imagine that the same that something similar happens in your field. Yeah. And the human operators have a tendency to kind of look at the kind of very recent past, whereas it would be better to look at kind of a longer past.
Yeah. Right. Well, your example seems to link up a little bit to the desire to let's say predict how many people will come into the building, auto or whatever kind of thing.
I would guess
so. There could be some elements of value there, but I understand your point. So, as a scientist, having sketched where we are today and what it's not, what do you think the next great breakthrough of science in AI will be?
Oh, that's hard to predict, right? So, if you would ask me, I guess that the solutions that we currently have with deep learning, it's kind of reaching some kind of asymptote, right? So it's not going to get a lot better than this. I mean, it's great what we got, right? So don't get me wrong, and we will definitely see improvements, but they might be gradual improvements. I think for the next kind of big thing to happen, we need a shift in paradigm, and we don't know what paradigm. So some people, for example, I talked about rule-based systems, right? We talked about expert systems, and so they have the feeling that we should somehow combine expert knowledge much more than we currently do with statistics-based models like deep learning models, right? Right. And that might well be, but we don't know how to do it, to be completely honest. Okay. Yeah. So if I think about self-driving cars, if you ask most people 10 years ago, they would probably say that we would now have self-driving cars, right? So today we had a lot of snow, would have been great. Yeah. We don't have them yet, right? Only in a very kind of, you could say simple conditions where there's not so much traffic and not so much kind of different things happening. It's fine. You can use self-driving cars, but in traffic, even here in Nijmegen, which is a relatively small city, no one has a self-driving car. It's far too dangerous. Right. The reason is that the statistics can bring us at some point, but then, so it's what we call kind of the long tail. So there was a very long tail of things that hardly ever happen. So it's very hard to learn, right? Right. But it's still very relevant because it can be extremely critical. Right. What we as humans do, if such cases happen, is we kind of go to kind of our knowledge-based system and say, okay, this is something that I've never seen before. Now let's break, or let's kind of move to the right, or whatever. So we can somehow change gears in a sense. We don't know how to implement that really in the current system. Right. So we are working on that, but we don't have a real clue how to do that.
Yeah, well, then you refer to...
This kind of common sense, or in Dutch we call it boerenverstand, farmers.
Yeah, farmers sense. It's kind of... So you actually refer to rules of how to decide within our own brain?
Yeah. I kind of logic reasoning.
In terms of these cars, is when I have to choose, am I going to hit the lady with the small carriage or the elderly person on the other side? What choice am I going to make, or whatever kind? And that's basically you refer to that kind of situation.
And the other very nice example is at some point in time, so they trained the Volvos in Sweden, and it could very well detect reindeers, but then they kind of imported them in Australia, and the kangaroos were kind of hit by all the Volvos. So it didn't happen, but it could have happened because it had never seen it. Yeah. So, and for us, I mean, we would probably recognize, and this is an animal. So so we can relate to that, and then we know what to do.
Right. Yeah. Right. So coming gradually to the end of the podcast.
Oh, that's a pity.
Yeah, it's actually a pity. I haven't so much to talk about, of course.
I got that.
And maybe perhaps you can continue the conversation later on. But in terms of if just very simplistic advice to anyone operating in a knowledge worker role for, in this case, a real estate facility management. What's your advice? What to do in terms of what you see coming in their field? How to basically compose yourself to this? What's smart to do just in practice on a daily basis? What are you going to do next year with this? Very simple.
Yeah, but there are so many people working in this area, so it probably also depends on what your role is, right? But if you're kind of working more at the strategy level, I would definitely keep an open eye towards solutions that AI might give you, right? So you have to kind of think about how to implement these into your organization, maybe do a bit of research and be open to it, but always keep in mind that you have to apply these methods in a responsible way, right? So it's extremely important. If you're kind of a knowledge worker who on a day-to-day basis works with facility management and with software and so on, then make use of the tools that are there, right? Like Copilot and things like that, because programming, for example, it's nowadays a lot easier than it used to be like five years ago or 2 years ago.
In that area, it's kind of a productivity tool.
Yeah, it's a productivity tool. So why not use it, right? So make your life easier, make your life a bit more fun. I would definitely do that. If I think about kind of people who have to make predictions, try to play with statistical models to improve your predictions and see what you can do there. But there is no holy grail yet, right? So it's not solved. You still have to work on that. So the tools that are out there, try to use them. Try to play with them, see if it works and makes your life better. Yeah. And on a strategy level, don't close your eyes, but make sure that you're aware of what can be done and what and try to implement that in a clever
context in which AI can be applied in a sensible and
and make sure that you have an understanding of kind of different types of AI, right? And don't see it as kind of a container term that well, we cannot use AI or we can use AI, because there are different types, right? So ChatGPT is completely different from doing predictions for for occupation numbers or the type of models even that are used in cameras for doing vision, right? So completely different stuff, and be careful there not to generalize too much.
Right. So last question on this, because it's just in my head as we go in the conversation. These multi-language models, can you effectively use them for learning? Would you advise to learn? Because what I personally sometimes experience, okay, I don't know about this, let's ask something, and I get an answer, but I can't actually, because I need to learn, I can't really validate its answer, because I'm learning.
Yeah.
So
So I think what you will see, and you will already have it in Copilot, right? So that you don't just get an answer, but you also get links that can bring you to sources, right? And then you can check the sources. So that in that sense you can learn, and you can use it for learning, because once the sources are added, then you can check for yourself, and you can also determine whether you think that's a valid, reliable source, or whether you think it's crap. So okay, fine. So that definitely helps. The other thing, so my daughter uses it a lot, because what you can do is you have a piece of text, and then you can say, well, make me kind of questions, like multiple choice questions based on this text. So then you give it the text, and you just ask it to kind of rework the text to something that you can use to learn. And then the text is already there, so it cannot really make any mistakes. So then it's fine.
The context is clear then.
Then the context is clear because you give it the context, and then you can use it a lot, and it's really useful because you don't have to make those cards yourself, and the system can make the cards. So there are all these kind of clever techniques that are popping up these days that are extremely useful.
So with that, I thank you very much for being with us today.
Yeah, thanks a lot.
It's really a pleasure. I think there's going to be a lot to basically discuss in the years ahead, because this is certainly a central point of research going on in the coming years, of course, and development, for sure. For listeners, thank you very much for being with us today, and looking forward to see you next time. Thank you very much, Tom.
Thanks, Erik.